Good morning, this is your stat sensei, Mr. Spensei, and this is notes and the warm-up for chi-squared test of independence. So scenario, handling affairs. The responses from a random sample of 200 students from a large college of 35,000 students are recorded below. All right, so we have 35,000 from a large, and we have a sample size, and it's a random sample. That's good. So we have one sample. One sample of 200. So I'm going to just say n equals 200. All right. And we also have a population of 35,000. So then the students were asked their opinion about the following statement. The most important quality of a person who aspires to be the president of the United States is knowledge of foreign affairs. And they could strongly agree, some would agree, etc. At alpha equal 0.05, is there evidence of an association? I see the word association, and that's a super key word because that key word lets me know that we're probably talking about a test of independence. All right. Between gender and question response. Oh, gender and question response. Well, that's really important because that means I have two variables. So now I know for sure because I have two variables, gender and question response. Well, when I look at it, gender has two levels, so I'm just going to write two levels underneath that. And question response has one, two, three, 5 levels. All right. Answer the following in the space below. How many samples are there? Well, you said there was one sample of 200. It was a random sample. How many samples are there? We did that. List the variables and the levels of each. We listed the variables, gender and question response. We said that there are two levels of gender and there was 5 levels of question response. All right. So, and now they didn't give us totals on this, so that's going to be interesting for us. All right, so I'm going to flip over to our actual notes. And we already know that our formula is going to be the same formula. And by the way, this is page 289. So page 289. Our formula is chi-squared equals observed minus expected squared over the expected. All right, I'm going to go ahead and start my graph, even though I don't have the information. I know this, it's going to be skewed to the right. It's going to start at 0 and it's going to go to positive infinity. I know that somewhere over here, I'm going to have some sort of chi-squared value. I don't know what it is yet, but I'm still going to go mark it down. All right, so you're going to have to follow along really carefully because we really need to go find all the column totals, all the row totals, and multiply them and divide by the total. But we're going to learn a shortcut, but you have to pay attention. So blue button, and then the button that says matrix right here. All right, we're going to go over to edit and press enter. When I look at this, I have 1, 2 rows and 1, 2, 3, 4, 5 columns. So 2, enter, 5, enter. All right. So 10, 15, 15, 25, 25. And then we're going to go 20, 25, 25, 25, 15. All right, we entered the matrix. And now that we're really cool and we did that, we're going to leave the matrix. So we're going to just go second, quit, and we're out. Now we're going to go stat test, and we're not looking for a goodness of fit test. We're going to run a chi-square test. I'm going to press enter. Our observed is an A, and you're going, we didn't do our expected. And I'm like, trust me on this. And we'll press calculate. Hey, guess what? We now have our chi-squared value. And our chi-squared equals 8.922. And our p-value is 0.0630. 0.0630. All right. So we can't plug yet because we don't have our expected values. Oh, and it says our degrees of freedom is 4. Well, let's check that out. Remember, rows minus 1. Well, we have 2 rows, so 2 minus 1. And columns minus 1. Well, 1, 2, 3, 4, 5. 2 minus 1 is 1 times 4 is 4. Because once again, it's rows minus 1 times columns minus 1. So our degrees of freedom are 4. All right, let's see if we can get those expected values I've been promising you without having to do a whole lot of work. Let's go second matrix, arrow over the word edit, and arrow 1 down to letter B and press enter. And guess what? Those values are expected values. So I have 13.5, 16.5, 18, 22, 18, 22, 22.5, 27.5, and 18 and 22. All right. All I did was just copy down the values it gave me and put them in there already for me. So in this case, we can go ahead now and plug in because our formula is observed minus expected, and we know those. So chi squared equals 10 minus, 10 minus 13.5 squared over the 13.5. Because we're always going to do first and last. And remember, it's observed minus expected all over the expected. So now we're going to do plus dot 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 plus. And we're going to go to the last one, which is going to be 15 minus 22 squared over 22. And once again, it's observed minus expected over the expected. Inference procedure. All right, this is a chi-squared test of independence. All right, I'm going to pause the video for just a moment because we're about to have a bell ring. All right, welcome back. So we've gotten all the way to, we've named the test, we've done our calculations. We need to write our null and alternative. So I'm going to flip back over to a recipe. And our recipe basically says variable 1 and variable 2 are independent. Variable 1 and variable 2 are not associated. All right, variable 1 and variable 2 are not independent, and they are associated. Okay, so here we go. And I'm going to shorten that up just a little bit. Well, what were our two variables? Well, if we look back at our warm-up, we said our two variables were gender and question response. All right, so our null hypothesis is HO, gender, that's variable 1, and question response are independent. Now be real careful here. They are independent, which means they are not associated. All right. So that's our null. Gender and question response are independent, which means they're not associated. The ha is going to be gender and question response are not independent. And you're going to say they are associated. So let's pause just here for just a moment. Not associated are independent. And over here, not independent and are associated. So all we did was we flip it. Okay. So question response, gender and question response are independent. They're not associated. And gender and question response are not independent. They are associated. All right. Conditions. Well, first condition is always going to be the randomness condition. When we did this, we read that, hey, at the very beginning, when we read our warm up, we said there was a random sample of 200 and that was given to us. We have a random sample of 200 that was given. We found that in our warm up. All right. The next thing is the n is less than 10%. So we're going to go 200 times 10 equals 2,000. But we said earlier that our population was 35,000. So that's less than 35,000. So n is less than 10% of population. I'm just going to call it pop. All right. The next one, we need to make, so this tells us our sample, we have a random sample. This tells us our sample is not too big. The next one is it big enough? So all expected values greater than or equal to 5, see table above. And let's go check to make sure that that's actually the case. And I see the smallest one that I have is 13.5. So all my expected values are greater than or equal to 5. So we're good to go there. All right, the probability statement. Well, there's a probability that chi-squared, it's always going to be a greater than sign. Greater than what? 8.922. We got that when we ran this. 8.92. And I'm going to run it again. Stat test, chi-square test. 8.9225 equals 0.0630. And notice I had that all up on my graph, but I could also pull it straight off the calculator as well. Okay. All right. So my p-value is 0.0630. My alpha, they said, was 0.05. This is greater than. So our decision is to fail to reject. So our conclusion, our p-value is 0.0630, which is less than our alpha equal to 0.05. We fail to reject the null. There is not, remember, if we fail to reject, there is not sufficient evidence to suggest that gender and question response are not independent. All right. Now, real quickly, I'm just going to say right now, gender and question response are not independent. That is my alternative hypothesis. Gender and question response are not independent. Okay? And we don't need to add the associated part to it. All right. I hope that helped. Look forward to seeing you on the next one. Thank you.